capture the essence of the exercise. So it says that n ranges from 0 to 3. So we just need to write, okay, n set, and then the probability that n equals little n. So as you can see in here, I am taking the n ranging from 0 to 3, and I am touching point with the label of number 2. However, I will just capture the essence of this particular distribution without that point by putting a 0 in here. Okay, so it's the point here is just to keep the order of things. So we readily know how to solve these sort of exercises. However, we do not know what to do when we have one mass point left. When we are lacking one mass point. Okay, so in here we just put 0 in the probability, right? And in here that's 1. That's it. Okay. Now allow me to display it like this, and then I just have to write the distribution of x. I will just justify this to the right like this, and then I will start putting in here the x's. So what we have here is a distribution that ranges from 1 and to 10. Actually, it just has two mass points, 1 and 10. So is it possible for the s, that is for the random variable of aggregate claims, to equal 0? Recall that s equals s1 plus x2 plus all the way up to all the way to xn, right? So is it possible for the s to equal 0? The s cannot take on the value of 0 because you can have 0 claims. It is absolutely important to consider the mass point at 0. So it doesn't matter if the distribution of the severity has no mass points, for instance at 0, or if it just doesn't have any mass points at all. It just doesn't matter, because you see, as long as you have a mass point of the frequency random variable at 0, then you definitely need to consider that. So in here it can take on the value of 0, then of course it can take the value of 1. It's not necessary to consider all the other points in here. For the severity distribution, we only have 2 mass points, 1 and 10. That's fantastic, that's great. However, recall that we definitely need to capture the essence of this random variable. And this random variable, for instance, well, it adds up all of these random variables. So in this case, the n ranges from 0 to 3. What does that mean? Well, it means that, for instance, I can have only one of these random variables, or I can have 2 of these random variables, or 3 of these random variables. Well, actually, two will happen with probability 0, right? However, we should consider it. That is for the sake of completeness of the exercise. Now, the point of this whole exercise is precisely the sake of completeness. So the name of the game here is completeness. So in this case, we see that, okay, we're missing a 2. Okay, doesn't matter, because we just take the probability that n equals 2 equal to 0. So that's it. And in this case, we have a lot of points between 1 and 10. However, for the sake of completeness, we should take all the other points. Now, what are the other points that we should be interested in? Okay, so the very first one of them is, of course, this one here, right? Now, so you can okay, should we take a 2? Yeah, because we can have 2 claims, right? Each worthing precisely 1. So 1 plus 1 equals 2. Now, for the same reason, we could also have 3 claims, each worthing 1. So 1 plus 1 plus 1 equals 3. That's it. Now, should we consider the point of 4? Okay, no, because we cannot have 4 claims. In here, it says that the maximum number of claims available is of 3. So we do not need to consider number 4. The same goes for number 5, for number 6, for number 7, and so on and so forth until number 10, which is the case of having 1 claim with $10, 10 pesos, 10 whatever, right? Now, can we have that the S equals 11? Yes, because we can have, for instance, 2 claims, one of value 10 and the other one with value 1. So 11 is possible. 12 is possible. Yeah, because we can have 3 claims, one worthing 10 and the other 2 worthing 1 and 1. 13 is not possible, is it? It's just not possible. However, we should consider 20, 21, 22. Why not? So in order to have a 22, we would need to have 1 10, 2 10s, right? And 2 1s, but that's not possible because the frequency random variable ranges just from 0 to 3. The last value is just of 30, because in here we're talking about having 3 claims, each worthing 10, 10, and 10. That's it. So this here will be the range of a random variable of aggregate claims. Now, what we will do here will be to capture the essence of what? In here, I will consider this column here, I will consider the probability that S equals little s, given that n equals 0. So in here what I have is just the range of S, the support of the random variable S, and this 0 here is just the same as this other 0 around here. As for this column, well, in there I will put the probability that S equals little s, given that n equals 1. This 1 here. And the S is just this S here. Now, in here, I will just put the probability that S equals S, given that N equals 2. I know what you're thinking. You're thinking, but the probability that N equals 2 is just 0. Okay, yeah. So we'll just do this for the sake of completeness. Okay? And finally, in this other column here, we will just display the probability that S equals S, given that N equals 3. This 3 is this 3 around here. I will start, and I will leave you to complete the chart. So first, what we need to do is here, I just said that I needed to have the probability that S equals whatever, given that N equals 0. So in here, this is very simple because we just have a 1. All the others are zeros. That's it. I will use this other display here. And okay, I will also justify this to the left, like this. So there is no confusion between the N's and the S's. And then, okay, I will add some borders to this thing over here. Oops, I didn't do anything. Okay, there. So now I have this thing here. And of course, maybe I should add some borders to this thing here as well. And maybe also to this other thing here as well. So that what we have in here is just the distribution of n And in here, I just have the support of the random variable s. In here, I should just display what? Well, the probability is that s equals these values, given that we have only one claim, right? Now, what is the probability that s equals little s, given that we have only one claim? Well, in that case, we only have the probability that x1 equals s, given that we have only one claim. And since we already know that one of the hypotheses of the model of collective risks is the independence between the x and the n, then this thing is just the probability that x1 equals s. So the only entries in our chart, in our column, that will not be equal to 0 will be 1 and 10. We just need to find out what numbers should we put there. So for 1, we need to put 0.9, that's it. And for 10, we need to put 0.1. And as for the others, okay, we can just put zeros. That's it. So what is the probability that s equals little less, given that we have only two claims? Well, that probability equals the probability that x1 plus x2 equals s, given that n equals 2. And because we have the independence between the x's and the n, then this is just the probability that x1 plus x2 equals s. So we're talking about a convolution between x1 and x2. And since x1 and x2 are identically distributed, then what do we have? Well, we just have to convolute x with itself. So I'll just let this go and use this column to represent the convolution between x and x. So now, in order to do that, I will do a little trick. My trick will be this. Okay, here I have the random variable, and then here I have x, and in here I have the probability that x equals x. The probability that x equals x, right? So we also need a random variable y. And we also need the probability that y equals y. See? Now, happily, these two, x and y, are just the same. So the only thing we need in here is just to add these two random variables. And how do we do that? Well, we just need to use the convolution formula. What is the probability that the sum equals 0? Well, that probability is just the probability that the first random variable is worth 0 times the probability that the second random variable is also 0. That's it. That's it. Now, what is the probability that the sum equals 1? Well, that's just the probability that the first random variable equals 0 times the probability that the second random variable equals 1 plus the probability that the second random variable equals, that the first random variable equals 1 times the probability that the second random variable equals 0. That's it. Okay, what is the probability that the sum equals 2? Okay, so we just need to go in one of the random variables downwards and in the other one upwards. That's all we need to do. No response. You see? That's a beautiful thing, because the probability that we have a 2 is of 0.81. Now, what is the probability of having a 3? Well, it's just this one, right? Times this one plus this one times this one plus this one times this one plus this one times this one. That's it. Okay. What about the probability of having a 10? Huh? Like this. Now, of course, we could just, since we know, because of what we're doing, it suffices just to go downwards in one of them and upwards in the other. And since we already have this graphic vision of what we're doing, so what is the probability of getting an 11? Again, like this, like this. You see? This is really simple. This is really simple. There. And now all the others are just where the 0. Now for the 12, there. This one times this one, and this one times this one, and this one times this one, and this one. Yeah, there. And for the 10, for the 20, it's just the same. And now maybe some of you are thinking, man, you just have to multiply the probability of getting a 10 times the probability of getting a 10, and that's it. So why do you have to do all that? Now, the reason for which I'm doing this is just the key of the exercise. Remember, completeness. So we mean to be consistent with the formula, with the approach that we set at the beginning. So let us just try to be consistent, because here I'm missing about 6 values, right? And in here I'm missing 7 values. In here I'm missing 8 values. For this occasion, right, I will just allow myself to do this because we definitely mean to complete the exercise, right? So what is the probability of getting a 0 when you just add up 3 random variables? 0, 0. Of obtaining a 2 is this, and what the probability of obtaining a 3 is the probability of obtaining what? A 1, a 1, and a 1. So it's just this times rise to the power of 3, right? The probability of obtaining a 12, sorry, is the probability of obtaining what? 1 10 and 2 1s. How many ways are there to get that result? 1 10 and 2 1s. So it can be just the first random the first claim, the second claim, and the third claim. Yes. So in here we mean 3 times this times this rise to the power of 2, right? And 30 is just this to the third power. And here we just need to do this. Oops. And the probability of obtaining a 21 is just 2 tenths and 1 1. So here we just write 3 times the probability of obtaining 2 tenths and 1 1. That's it. So I sort of cheated in here. I mean, I cheated because I mean to complete the exercise. However, the results are accurate. As a proof, I offer you this row here. So I put a binomial coefficient of 3, right? Because there are 3 ways of obtaining a 21. That is obtaining 2 tenths at first and then a 1. The second possibility is to obtain 1 10, then 1 1, and then another 10. And the third possibility is to obtain a 1 first, and then two tens in a row. The same goes for the 12, because when you have 3 claims, then there are 3 ways to obtain a 12. That is 1 10, and then 2 1s in a row. Then you can have 1 1, 1 10, and 1 1. And the other one is 2 1s in a row, and finally a 10. Now, what is the probability that S equals S? Okay, now, in order to display this column here, I will use another very important color for us, and that color will be this yellowish color. Okay? This is just some product of all these with all this, and then I fix this range, and that's it. So the probability that S equals 0 is of 0.5. Please observe that the probability that S equals 0 matches the probability that N equals 0. Now, this would definitely not be the case should we have something different than 0 in here. Why is that? Well, because the only reason for which the mass point of the distribution of S at 0, right, is just like this, just matches this number here, is that we do not have a positive number in this column here. Why is that? Because we're using a strictly positive random variable for the severity. Now, this should more or less always be the case. Why? Well, because if a person goes to your insurance company to try to file a claim, then that person should be expecting to earn a little bit more than just 0. So normally, you will have that the random variable for the severity is a strictly positive random variable. So what we have here, this is the mass function of the random variable of the aggregate claims. We can verify, we can further verify that all we know so far just adds up, right? To what we think should be the proper knowledge of this course, right? Now, to verify that, well, a good idea would be to compute, for instance, the expectation of the random variable S. Now, what is the expectation of the random variable S? On the one hand, we have that this expectation is just some product of all these with the support of that random variable, like this. So on the one hand, we have that the expectation of the random variable S should be given by this expression here. The red range stands for the support of the random variable, while the blue range stands for the mass of the random variable. On the other hand, we also have that the expectation of the random variable S should be given by what? Well, by the expectation of the random variable X times the expectation of the random variable N. And what is that? Well, that is just the formula summa producto of this range here, oops, like this, with with this range around here times summa producto of this range here, with this other range around here. So now we can verify that our computations are correct by two different means. The first one is to see that you are effectively adding up to 1. That's just the first way to verify that you're correct. Now, the second way to verify that you're accurately computing is to take, for instance, the expectation. So the first one is just to take the definition of the expectation. The second one is just to take the formula that I taught you in the first part of the course for the expectation. So you have mass, expectation. Okay, now we need to compute the variance of the random variable S. Now, in order to do that, well, we need to compute first the expectation of X, variance of X, and also the expectation of N, and also the variance of N. So what is the expectation of X? Well, In order to take the expectation of x, we just need to take suma producto of what with what? Of this with this. There, like that. There. Happy, fantastic. And then we need to take the expectation of n, and that's just suma producto of this vector with this other vector here. That's it. Okay, and now we need to take the variance. Now, in order to do that, what we need to do is just to take what? This minus the expectation of n, right? Fixed, rise to the power of 2. And that's it. These here represent the value of the random variable minus its expectation rise to the power of 2. That's it. So what is the variance of n? Well, that's just suma producto, right, this vector here with this other vector here. And there we have the variance of n. Now, to compute the variance of x, then what we need to do is just to take another column, right? And okay, here I will represent x, no, x minus the expectation of x squared. That's it. So we just need to take this minus this fixed squared. That's it. So what is the variance of x? Well, the variance of x is just suma producto, what with what? This thing around here with value of these probabilities around here. Yeah, that's it. Okay. So the variance of s equals, according to our formula, the formula which we learned in the last term, when in the last part of this term, the variance of s equals the expectation of x squared times the variance of n plus the expectation of n times the variance of x. So we just need to type in this formula. What is the variance of s? The expectation of x squared. So this rise to the power of 2 times the variance of n, which is this number here, plus the expectation of n, which is here, times the variance of x. We can also take the variance of s in another way. So all we need to do now is to have another column here, right? For s like this, s minus the expectation of s squared there. And all we need to do is to take the s, which is this here, minus the expectation of s, which is around here, fixed. And then I'm going to rise it to the second power, and then do this. And finally, I can compute the variance of s by writing suma producto of this vector here, this vector here, right? With this other vector around here. Easy peasy, lemon squeezy. So we're very happy about this because now we have not one or two, but three ways to verify that our computations are correct. The first one is to use the theorem of total probability and see that in the end, all of these probabilities add up to 1. The second way, to take the expectation of both in both ways. the one we learned in the previous part of the course, and just by means of the definition of the expectation. And third, you can just use the formula, this formula here, for taking the variance, or we can use the definition of the variance, and that's it.